Related to the manufacturing, limits, fits and tolerances. Limits are the maximum and minimum dimensions of a product which is manufactured. The minimum and maximum sizes of a product are determined for several reasons. The one of the reasons is, let us say, if a shaft has to be made with 50 diameter, the shaft is placed in bearings. That means the inner diameter of the bearing should be greater than this 50 and several things like gear wheels or flywheel or pulleys are mounted on the shaft whose internal diameter should be greater than the diameter of the shaft. The dimension of the inner diameter of the bearing or flywheel or pulley, if it is greater than the dimension of the shaft by 1 or more, what is going to happen? There will be relative motion occurs between them. We should have the relative motion between the bearing and the shaft, but we cannot have relative motion between the pulley or flywheel or the gear wheel which are mounted on the shaft. So therefore, these must have a dimension which is very close. That means the inner diameter of those things should be very close to the outer diameter of the shaft. So the products with dimensions, whether the outer dimension of a shaft or inner dimension of the different wheels which we have mentioned right now, those things should be manufactured, and the manufactured items, let us say the 50 diameter shaft has to be placed in the bearing. The dimension of the bearing should be greater than 50 but the commercially available bearings are either 50 or 60 Then what we need to do? We need to grind, or we need to bring down the dimension of the shaft by few microns or up to a maximum of 1 What happens if we do it by 2 or 3 What happens if you are making the shaft diameter and the bearing diameter as the same? If it is smaller in dimension, then there will be sliding. If it is larger in dimension, there won't be any relative motion between the bearing and the shaft. So therefore, we are going to determine the maximum and minimum dimensions for the two mating parts. Here the two mating parts are, one is the bearing, another is the shaft. So this is the bearing and this is the shaft. These are the two mating parts. We are going to define the maximum and minimum dimensions of these two things in order to have the defined fit or required fit. So between the bearing and between the shaft, we require a relative motion. In order to have relative motion, there must be clearance between them. That means the maximum size of the shaft should always be lesser than the minimum size of the hole of the bearing. The bearing hole with its minimum size should always be greater than the maximum size of the shaft. Then only there will be relative motion between the bearing and the shaft. So that is the main reason for having the limits when we manufacture the things. And fit, just now we have discussed that we require the clearance fit between the bearing and the shaft, but we require a different fit for the shaft and the gear wheel or pulley which are mounted on it. So they are having the same motion as that of the shaft. This is the shaft. Over the shaft we have a pulley. So pulley cannot go around the shaft. Along with the pulley, it has to rotate. So therefore, there must be a fit between the pulley and the shaft so that there is no relative motion. If you don't want to have a relative motion between them, you can have either the transverse fit or the interference fit. The interference fit is the one in which the minimum size of the hole is always smaller than the minimum size of the hole is always smaller than the maximum size of the shaft. So when the minimum size of the hole is smaller than the maximum size of the shaft, as well as the maximum size of the hole is lesser than the minimum size of the shaft, that means the shaft is having minimum dimension and the hole is having maximum dimension. In this case also, the maximum size of the hole is smaller than the minimum size of the shaft. This condition results in interference. Always there will be interference. If the shaft comes with minimum size and the hole also comes with minimum size, shaft comes with minimum size and hole comes with minimum size, the shaft cannot enter the hole. And now shaft comes with bigger size and hole comes with minimum size, definitely it cannot enter. But if hole comes with maximum size and shaft comes with minimum size, even in that condition also, if it cannot enter, then that is known as interference. So the minimum size of the shaft and maximum size of the hole, in that condition also, if the mating is not going to happen, then that condition is known as interference fit. So the transition fit is the one in which the maximum size of the hole is bigger than the minimum size of the shaft. When shaft is in its minimum size and hole is in its maximum size, okay, there can be mating possible. But the other way, when shaft is of the maximum size, whereas hole is of the minimum size, the mating is not possible. So this is the case of the transition fit. So these are the three types of fit. One is the transition and another is interference, and the first one we have talked about is the clearance. So these are the three types of fits. So depending upon the requirement, we will use or we will take up one or the other kind of fit. For the bearing and the shaft, we will choose the clearance fit, and for the gear wheel or pulley which are to be mounted on the shaft, we may go for transition fit. And when we are taking some kind of joints or a pipe is placed over another pipe, uh, whether it is HDP pipe or GI pipe, HDP or GI pipe in such and such conditions, or at least if you take a pen. So here you can see this pen, when it is placed over the cap is placed over the pen, it is very easily going inside. But when it goes to certain extent, you need to have a push. That means until this period it is having clearance, and then it is having some difficulty. So this is called transition fit. And when in entirety it cannot, the pen cannot enter the cap's hole, then that condition is called interference fit. So interference fit is useful in shrink fitting of the object, where one object needs to be placed in another object, will be heated, and when it is entered it can enter easily, but after cooling down the two will act together as a single component, and that process is known as shrink fitting. So in the shrink fitting category we are going to have interference fit. So right now you have interference fit and clearance fit and transition fit. Next, the tolerances. Tolerances are the dimensions which are allowed on the deviations are allowed on the dimension. For example, this is the shaft we are going to make, and the maximum size and minimum size we have defined. Maximum size is 50.1 mm and minimum size is 49.1 mm. So 50 is the basic size. So 50 is the basic size, and maximum size we are allowing is 50.1, and minimum size we are allowing is 49.1. And how much we are allowing deviation. So from the basic size you are allowing zero point 0.1 on the higher side and zero point 0.1 on the lower side. These are called the tolerances. So how much you are tolerating? You are tolerating zero point 0.1 on the higher side and zero point 0.1 on the lower side. So together how much you are allowing? You are allowing 0.2 mm. That's the tolerance. So you may allow it on only one side, that is called unilateral. If you are allowing it on both sides, you call it as bilateral. So when 50 is the basic size, if you are allowing above 50 as well as below 50, then that is called bilateral system. When you are allowing on only one side, that means if 50 is the basic side, you are going to allow 49.9, 49.7. So the maximum size we allow is 49.9 and minimum size we allow is 49.7. So 50 is the basic size. So you are not allowing the 50. So what you are allowing is 49.9, that is the maximum, and minimum is 49.7. So both are on the lower side of the basic size. This is called unilateral. And if you are having 50.1 on the higher side and 49.9 on the lower side, then that is called bilateral. So you can have the tolerances on either side. Next, the when you have a shaft and a hole, the system of tolerances may be based on either shaft based or hole based system. That means you keep the hole fixed and you are going to vary the shaft. Suppose you are not producing bearings, you are buying bearings from the market. So the bearing dimension is fixed, that is the inner diameter of the bearing is 50, and according to the requirement you are going to change the diameter of the shaft. So if you want a clearance fit, you will make the dimension of the shaft which can enter inside the bearing as 49.9 or 49.8, so that it can easily enter and it can have relative motion with respect to the bearing. And in case if this is not the bearing, this is a gear wheel which has to be mounted on this, and these two should not have a relative motion. Then what you are going to have? You're going to have its internal diameter as 50, but the maximum size of the hole you are keeping it as 50.1, and minimum size of the hole you are keeping it as 50, and whereas for the shaft you are keeping the maximum size is 50 and minimum size is 49.99. So in that case what can happen? You need to enter the shaft when the minimum size of the shaft is 49.99, whereas the maximum size of the hole is 50.1. Okay, it can enter easily, but when the minimum size of the hole is 50 and maximum size of the shaft is also 50, in this case you need to have some kind of mechanical pressure. Either you need to hammer, or you need to apply some hydraulic pressure, or you may need to apply some kind of shrink fitting. You are going to heat it and enter into that, and after cooling, that two will together act as a single member. So depending upon the uh, convenience, you are going to use either the hole based system. That means depending up, we are keeping the hole as fixed and we are going to change the shaft, or you may fix the size of the shaft fixed, and you are going to change the internal diameter of the hole. That way you are going to have the shaft based system or the hole based system. And the next factor for the manufacturing is the type of quality of surface finish. We are very clear that from different manufacturing methods we are going to obtain a different surface finish. If a member is casted, then it will have a rough surface finish. When you have machined that, you will have definitely a better surface finish. When you are going for grinding, you will have much better surface finish. When you are going to have some operations like lapping or horning or reaming, depending upon the surface, outer surface or the interior surface, the the surface will become much more smoother, and it is known as mirror finish. So the mirror finish or very high surface finish is essential for components which are subjected to fatigue loading. When the objects are under the fatigue loading conditions, you require very high surface finish. When the objects which are under the fatigue loading conditions, if they are having surface imperfections, then those surface imperfections will be the starting point of the crack. So crack initiation takes place at that point, and then crack propagates, and finally the fracture will take place. In order to avoid the fracture of the member very quickly, we are going to have the surface finish under the fatigue loading conditions to a very high degree of smoothness. Next, let us talk about the protective coating requirements. The protective coating requirements, uh, it is to have a very good corrosive resistance, and it is also to give the pleasing appearance to the eye, and also it is the convenience of handling. So the protective coatings will be pleasing to the eye. They are going to make the member to last for long without rusting, etc. And also some kinds of paintings or protective coatings will give grippy surfaces so that the handling will become dexterous. Thank you.